I made an executive decision this afternoon, and I decided that, you know what, we always tend to go alphabetically. So poor Mike Zummo is always the last one on the list. So we're going to go in the opposite direction today, and I'm going to ask Mike Zummo to make today's first presentation. So Mike, come on up.
Thank you, Jill. Well, that was a curveball. I thought I was going to go last today. I think I went first at the first of these forums that we had, so it's not too bad. I'm Mike Zummo from Messiah College. I'm the principal investigator of a federal biodiesel research grant that we have at the college. I work within the Department of Engineering as well as the Collaboratory for Strategic Partnerships and Applied Research. There is some information on the registration table about both the biodiesel project and the Collaboratory. I'll also be here for more questions, and you also heard that Dr. David Vader and Todi Kando are here to talk more about either. Actually, all the Messiah representatives can tell you more about the Collaboratory here. The work I want to talk about today is specifically our biodiesel research. We've been working in biodiesel for almost a decade at Messiah. The last 3 years, we've specifically been working with a Department of Energy research grant in the renewable energies and energy efficiency area. We are specifically working with waste vegetable oil as our biodiesel feedstock at the moment, hopefully moving towards some newer crops in the near future. Before I get started, I'm going to talk a lot about our technology, but Jill had asked that we specifically address the areas of commercialization. And I'll say that now so that as we go through, you can make your own implications as to how they fit into where I think they fit. The major areas we're looking at are small-scale individual or institutional applications, so someone that wants to make biodiesel on their own, or a college, hospital, or really any organization that may have access to feedstock. The second would be the educational aspect. We've gotten a lot of interest from schools and other colleges about adding this to their curriculums for teaching students about renewable energies and showing them how simply biodiesel can be created from something that is typically a waste. And then the third and final area of commercialization potential is developing world applications. And that's really where a lot of our projects in the Collaboratory fall, is working in the developing world. And obviously this fits into that as an alternative energy source, or potentially a way to have a liquid fuel where, I got to stand by the microphone.
Yes, you do.
Thank you, sorry about that. To have a fuel that they may not have had otherwise. So as we go into the technology we're working with, that's the areas that we see. At Messiah, our goal is to have a full circle, full use process with our vegetable oil. So as I said, we are starting with the waste at this point. We solely collect the waste vegetable oil from the college and convert it to biodiesel. In the process, we really work in 3 areas. Oil purification, we want to get the oil as clean and as high quality as possible. Then obviously biodiesel production, where we want to improve on systems and make higher quality biodiesel. And then thirdly, an area that's not as much talked about in small scale research is methanol recovery. And I'll address those 3 as we move forward. All biodiesel starts as a feedstock. We are starting to work in growing our own feedstock on campus, very small, scalable projects that we hope to actually press the oil from the crop, use that oil for cooking, and then convert it to biodiesel after it's considered a waste. The newest area of our research is actually the seed pressing, which doesn't make a lot of sense, but considering that we started with waste oil, going to a clean oil is new for us. So we last year acquired several pressing mechanisms so that we can begin pressing our own oil. This is an area where we can really apply it in the developing world. There's not a lot of good mechanisms for creating vegetable oil in the developing world, and to be able to take some of this equipment there could really open up the door for biodiesel in some of the locations that we have relationships already. Like I said, we want to use the cooking application first. If we're going from a straight oil to biodiesel, we're kind of thwarting a major market. So if we can get oil to a high quality level that it can be cooked with first, it actually fulfills 2 purposes, for food and then for fuel, so that we're not entering a potential conflict where we're taking food from college land or from a developing world community that needs food before they need fuel. As I mentioned, our main area for the last decade has been waste vegetable oil. We collect vegetable oil from our own campus and a couple businesses in the Grantham, Mechanicsburg, Dillsburg area, bring that back to Messiah and purify it. This is one of our newer systems where we're actually taking waste vegetable oil and running it through an inline centrifuge with the hope of achieving a higher quality oil to start with, which makes our biodiesel in the end higher quality. We've had very good success with this system to date. We're also looking to integrate a similar system on the back end of our biodiesel production process to filter out any particulate that may remain or glycerin that's still remaining in the biodiesel. This system is the system we've been working with for probably 7 of the 10 years that we've been at Messiah. It's a very simple system. All the plumbing is actually PVC, a very simple pump, 3 tanks. This is something that could be applied to a high school or a middle school where students can turn valves and see fluid move from tank to tank and understand the process. This is also a very simple system that could be applied in a developing world setting for easy maintenance and easy understanding. This system probably costs about $600 to make. It's, like I said, very simple. I personally call it our Home Depot system because most of the parts are things that we can get from local hardware stores. Obviously, that's not enough for us as mechanical engineers at Messiah College, so we're now moving to a PLC, a programmably logic controlled system that will actually be fully automated. It'll be a single tank reactor with multiple tanks for the products that are created from it. What you see in front of you is basically the hardware side, our valves, pumps, and our plumbing on the system. We're in the process now of programming the PLC and building that system. I was fortunate to have a computer and electrical engineering student as my intern this summer because I do not know how to program a PLC on my own, and he's been wonderful to have. So that'll be a system that will be more marketable in the institutional or individual arenas. We've been at the farm show for the last 3 years presenting the project and have had probably 30 to 50 inquiries every year about where they can buy a system like what we have. So this is really trying to meet that need. This system will obviously be significantly more expensive than the previous one that I showed you, probably upwards of $3,000 in the end, and we are still at the very early stages of this development. We have not done any actual testing yet. The next area that I mentioned earlier was methanol recovery. In the biodiesel production process, you produce 2 products, biodiesel and glycerin. The glycerin byproduct contains a significant amount of methanol. Unless that methanol is removed from the glycerin, it's actually hazardous to dispose of it, and you're actually throwing money away. That methanol can be recovered and reused. So these 2 systems that you see, the system on the left is our initial prototype that we built several years ago. The system on the right is our newer prototype, and the next slide you'll see the completion of that model. 2 years ago we received funding through the Keystone Innovation Zone grant through Innovation Transfer Network to begin that research, and this is the culmination of that work. This is a functioning system. When I left Messiah today, the system was running, recovering methanol of 93 to 95% consistently, and creating a glycerin byproduct that is safe to dispose of. This is really where we'd like to see people asking us the question of where can we get a methanol recovery system, because without this, your biodiesel production process is actually incomplete. You're really not processing your products to their fullest, and you're not getting the most money back out of it for yourself. Another key aspect of what we've done at Messiah has been education. We have been in a number of schools doing hands-on workshops and demonstrations. Just recently I was at Milton Hershey for 3 days doing biodiesel hands-on workshops with 6 different chemistry classes each day, where we actually made biodiesel from Milton Hershey's own vegetable oil, washed that biodiesel, and then put it in one of their gators to show the students the full cycle of producing biodiesel. So that's an area where we see a lot of opportunity to take a simple reactor, implement it at a school where students can actually be making a renewable fuel. One of the other key areas that we're working, and this is specific to our developing world application, is in potentially processing a jatropha feedstock. Anybody who knows a little bit about biodiesel has probably heard of jatropha. It's actually a non-edible toxic oil. The plant produces non-edible toxic oil. This plant will grow pretty much anywhere. It is not an annual plant, so it will grow for up to 30 years, producing 2 to 3 harvests of seeds every year. There's some of the highest oil-bearing seeds that biodiesel researchers have seen to date. And I had the opportunity last summer to work in Burkina Faso with this crop a little bit. This is really where the need for our pressing development came. They had lots of jatropha seed and not a good way to press it. In the States, we don't have a problem finding oil. Over there, they do. So we initially did some work on drying the beans, very primitive, as you can see, and then some very basic work on pressing. And like I said, our pressing research came out of this. We want to take a more comprehensive pressing system back to the community in Burkina Faso and learn how to press these jatropha seeds better than they're currently doing it now to produce oil that they can use to power their diesel vehicles. There's not really a heating need, but there is a minimal cooking need, and to power backup generators for the facilities that are over there. When I went to Burkina Faso last summer, I wanted to bring a test reactor, so this is what I called my duffel bag reactor. This whole system fit in a duffel bag. Somehow I made it through customs from JFK to Burkina Faso. The heating element kind of looked like a pipe bomb, and I was a little nervous about that, but we survived and the system got installed. We did attempt to make some biodiesel with minimal success. The oil quality there was very low compared to what we're used to working with in the States, and the quality of our ethanol in that case was also very low. So we didn't have a lot of success, but we did leave a reactor behind. We actually have 2 Messiah Engineering alumni who work at the facility that have made biodiesel themselves. So they have this now to work with as they go forward. So that's the work we're doing with biodiesel at Messiah College, and I'd be open to any questions you may have now.